I scored a 524 on my MCAT. Let me show you how you can do it too.
Suppose that in a randomly mating population of mammals, 160 of its 1,000 members exhibit a specific recessive trait that does not affect viability of the individual. How many individuals in this population are heterozygous carriers of the gene that causes this trait? So here we have to use the Hardy-Weinberg equilibrium principle. And there are two equations associated with Hardy-Weinberg equilibrium. Okay, and one of them is going to be as follows, that 1 is equal to p squared plus 2 multiplied by p times q plus q squared, where p, okay, is going to be the frequency of the dominant allele, and then q is going to be the frequency of recessive, okay, allele. And therefore, p squared is the frequency of the dominant phenotype, homozygous dominant phenotype. 2 times p times q is the frequency of the heterozygous phenotype, and q squared is going to be the frequency of the homozygous recessive phenotype. And then the other useful equation is going to be 1 is equal to p plus q. So frequency of the dominant allele plus the frequency of the recessive allele. So they actually give us the frequency of the homozygous recessive phenotype, right, which is 160 of 1,000. Okay, and therefore, that's going to be the frequency of the homozygous recessive genotype, right? So q squared, okay, is actually equal to 160, okay? Or specifically 0.16, because that's going to be 16% of the 1,000, okay? So you want to have it equal a decimal. And so the square root of that is simply going to be q is equal to 0.4, okay, 0.4. And so then q is 0.4, so p, because we need p as well, p has to be equal to 0.6, because 0.4 plus 0.6 is equal to 1. Okay, and we're trying to find the number of individuals that are heterozygous carriers of the gene. So we need to find this 2 times p times q. Okay, so the answer is going to be 2 times 0.4, okay, times 0.6, which is the same as 2 times 4 over 10 times 6 over 10. Okay, so that's going to be simply 100 down here, and this is 8 times 6, okay, which is going to be 48. So it's going to be equal to 48 over 100, or 0.48, which times 100% is 48%. Okay, and there 48% of these 1,000 individuals are going to be heterozygous, so 480 of them will be heterozygous.